Today we are going to talk about project time management. Managing schedules is a very important activity for a project manager. If you had to ask some project managers as to what is the major cause of conflict throughout the life of the project, the answer will be schedule issues. Why schedule issues are so common? There are many reasons. For instance, the simple reason is that the time is very easy to measure. Measuring cost and scope of the work is far more difficult than measuring time. Another simple reason is that there is no flexibility, it just passes by whether you like it or not. It is not a matter of throttling it, keeping it, holding it back. Okay. And another particular part is that the planned and the actual times are often compared without reference to the changes that might have occurred to the scope and other aspects of the project. So, you just blindly compare the plan and the actual, and then you are complaining that the schedule has not been kept up to date. So, this brings out that time management is a very important activity from a project manager's point of view. Okay? And the time management processes are aimed at first ensuring timely completion of the project, and second confirming that the triple constraints of scope, time and costs are balanced. Okay. So, project time management processes often lead to clarifications in respect of the work breakdown structure, okay, and or generating more supporting details for the scope activity that we considered earlier. If the estimated completion date for a project was to change significantly, it is very important for a project manager to go back and renegotiate the triple constraint of scope, quality and time with the top management. Okay. So, now let us look at the slides and see what are the main time management sub processes are there. First, we have activity definition process. Second, activity sequencing process. Third, activity duration estimating process. Fourth, schedule development process, and fifth, schedule control process. Now, remember, some of these terms may look quite self-explanatory, but we need to study them in detail. And one thing needs to be clarified: in case of small projects, many of these activities are often performed simultaneously, by the same individual. And from that point of view, you may not see these processes operating sort of one after another, but they may operate concurrently. Now, let us look at first the activity definition sub process. Let us look at activity definition sub process. The activity definition process involves identifying and of course documenting the activities necessary for producing the deliverables. And this has to be consistent with the deliverable breakdown structure that has already been defined. Incidentally, activity is basically, we have already seen, something that consumes time, requires resources and ultimately costs something to the project. Now, sometimes it looks surprising that why the identification has come in the schedule rather than or being duplicated after the same having already been considered in the scope. When we considered the scope management, we came out with a work breakdown structure. Similarly, there is a deliverable work down structure. There is a many to many relationships between the work and the deliverables, and from that point of view, you need to establish exactly what kind of activity is going to be performed before you can finalize the schedule for any particular project. How do you go about doing it? The first particular technique that you use is of course decomposition. Take the job and break it down to a reasonably small activities which are individually identifiable and monitored and controlled. In this respect, it is possible to use standard templates. Templates are also what we call available for resources required, for expected deliverables, for associated risks and so on and so forth, and these templates come very handy when we are trying to identify the activities for schedule development. So, activity definition process sometimes may result in causing changes to the work breakdown structure. For instance, if you were to identify a missing deliverable in this particular process of relook, you may have to go back and make changes to the work breakdown structure. You may have to go back and change. So, what we are doing basically here is we are now going to look at these particular activities in the second process and convert that work breakdown structure into some kind of a precedence diagram. Okay, diagram is only for our convenience, but we need to establish the precedence between the various activities. So, if you look at your screen, you will see that we have a work breakdown structure which needs to be sort of converted into a precedence relationship for all the activities, the precedent relationship for all the activities. So, this process basically this done is the activity sequencing subprocess. Activity sequencing process involves identifying and documenting. Mind you, the identification always follows documentation, identifying and documenting the logical relationships between the identified activities. Okay. So, you need to have work breakdown structure, product description, assumptions and constraints and all these particular things as your inputs, and based on that you can now establish the relationship between the activities. Now, the dependencies between the activities can be broadly classified into three groups. The first particular one is called mandatory dependencies or hard logic as it is sometimes called. Okay. So, between these particular activities, all these activities are incidentally within a project, there is an inherent relationship which goes by the nature of work. For instance, we cannot test a program unless the code is written, and there is no amount of hair splitting is going to change this particular kind of a relationship. Okay. The second particular set of dependencies are what we call external dependencies. Here there are things which are outside the control of the project and you need to depend on it. For instance, if somebody else was to give you hardware and you were to install your software for doing the job, and if hardware delivery was not a part of your project, then you have a situation where you can't do your loading until somebody has delivered the hardware. Similarly, in case you have to buy some software, you can't do that buying until the budget is approved, which is usually done outside the project scope, done by somebody in the organization to approve your budgets. Now, there is a third set of dependencies which we call discretionary dependencies, which are self-imposed dependencies between the activities of the project. Mind you, these are also within the project activities. Okay. For instance, we may have a concept of not beginning the design work until the SRS is reviewed. Okay. Or you might say that we will not start work on the project till SRS is signed by the client. You may also have situations where you might require exceptionally higher constraints, in terms of coding and errors identified and all that kind of a thing as a precondition before you start the next work. But these are discretionary dependencies, in the sense that it is a project's own imposition of the dependencies. Okay. So, basically we have mandatory, external and discretionary dependencies. Discretionary dependencies also sometimes called as soft logic. Okay. So, once you got this particular relationship, what are the ways in which we can organize this job? And we say the job is organized, by identifying either your precedence relationships, in the form of a ADM network or a PDM network, ADM network or a PDM network. So, let us first begin with looking at a precedence diagramming method, PDM method. This particular method also is known as activity on node kind of a network. This is also known as activity on node kind of a network. It depicts the activities on the nodes, and the activities are connected to each other by the arrows, or the events are basically shown by the arrows. The advantages of a PDM network or a ADM network, which we are used to looking at, is that it does not involve use of dummy activities, allows depiction of different types of relationships, more than one. Otherwise, end of one activity is the beginning of next activity, is a very common kind of a relationship. And most project management software also support these particular types of dependencies. So, now let us look at what type of dependencies do we have in PDM network. So, now let us look at here. The first particular dependency that we have is called finish to start dependency. Now, the finish to start dependency is the most simplest and the one that is also found in the ADM, arrow diagramming method. That is, that the task B cannot start until task A is complete. Okay. Installing a network card on a PC before connecting it to the network is a very good example, or a simple example of a finish to start kind of a relationship. The second type of relationships that we have is start to start relationships. What start to start relationship basically means, that the two tasks A and B, the preceding task A and the succeeding task B, must start at the same time. Okay. So, if you are planning for a physical implementation of a network and determining an IP address of the configuration, both these particular things can, to some extent start simultaneously. Okay. So, when many tasks must start simultaneously, then we have a start to start relationship. Okay. The third particular type of relationship that we have is finish to finish type of a relationship. In finish to finish relationship, just like the start to start relationship, the two activities are required to finish at the same instance. Okay. So, rolling out of a new software and completing the user training probably need to occur at the same time, or in case you are releasing a particular software at multiple locations, then that release must happen, must coincide at the same particular time. What it means is many tasks must end simultaneously together in that particular sense. The fourth kind of a relationship is a start to finish, is more difficult to observe, where we say that the preceding task A cannot finish until the succeeding task B has started. In a very trivial kind of a example, in case you are having a relay race, then you find that there is a overlapped running by the two players, the one who is giving the baton and the one who is taking the baton, and the activity of the earlier fellow cannot finish until the next fellow has taken the baton and got hand. Okay. So, we say counting network jacks that are installed after having, after they have been installed, is the activity that the, counting cannot be complete until the installation work, is also finished. Okay. So, the activity counting installed jacks cannot start unless the activity install network jacks is complete. Okay. So, this type of course, please remember, in most of our day to day sort of situations, we do not use many of these particular kind of relationships, and of course, finish to start is the most commonly used kind of a relationship, So, in case we were to look at these particular, now look at the slide again, you see an example of a PDM network. You see an example of a PDM network. Okay. So, PDM network basically is going to have all the activities on the boxes, with the starting time, finishing times and other description there, and the sequencing is determined by the arrows. Now, another important type of network that we have is arrow diagramming method, or ADM network. Is an illustration. Again, see the slide. We have an illustration of a arrow diagramming network here. Now, this particular network, okay, is basically activity on arrow. Now, as against the PDM network, we put the activity on the arrow and the events on the nodes. Okay. It uses basically only one type of connectors. So, that is start to finish, or like whatever you finish, then you end up there in that particular sense. And here we may use dummy activities. Now, again look at the particular activity E, look at the diagram on the board. Activity E, for instance, is a dummy activity, okay, and from that particular point of view, there is a mistake. It should not be showing any kind of a value on it, but this indicates that if two activities are likely to have the same starting and the finishing nodes, we may need to add a dummy activity to make sure that the diagramming notations are conformed to. Okay. So, in this particular manner, we can show the releasing. Okay. So, we have either a ADM or a PDM kind of a network on which we can show the precedence relationship between the various activities that the project is supposed to perform. Now, once you have done the identification of sequence, the next particular thing is that individual activity we need to do estimation. So, activity duration estimation process involves developing a time frame for all activities. Please remember, here we are not estimating the time for total completion of the project, we are trying to estimate the time required for individual activity. Okay. So, these activities are going to be progressively elaborated, and then the total time required for completing the project will be identified. So, activity duration includes both the time required for doing the activity and also if there is a elapsed time requirement associated with completion of that particular activity. Okay. Again, these estimates can be done both either probabilistic or deterministically, though we do not very often go into probabilistic kind of estimation, because it requires yet another level of sophistication in doing analysis of the network, analysis of this particular network. Now, project management software can take care of some of these elapsed time differences by using alternative calendars and so on and so forth, but many times you will have to manually establish the relationships and put the estimates physically there, for making this particular schedule workable. Now, one of the things that you need for estimating is different calendars, and that is, there are situations like, for instance, take holidays. If you have a project going on in Middle East and they follow, Friday as a weekly off and you are having a Monday as a weekly off, certain amount of problems will come in estimating the time required for completing if there is a dependency between the activities. Okay. So, in this particular aspect, it is very desirable, that persons or groups of persons which are most familiar with the nature of the activities should be involved in providing the inputs and estimating the durations for these particular activity. Of course, approving the duration must be also done by the people who are likely to be working on these particular projects, So, after we have done identification, sequencing and estimating, now we come to project scheduling. See the board again. What you need to now convert is to convert your precedence diagram, okay, convert your precedence diagram that you have into a schedule which will be acceptable or implementable. from your particular point of view, what you need to do is, identify the precedence relationship, look at the availability of resources, okay, and estimates for individual activities, and put all these three together to come out with a realistic kind of a schedule. The activities, their estimates, sequencing and resources basically form the input for making a schedule. Please let me again remind you, sequencing of activities is very different from making a schedule. Schedule has an implication of deploying or committing resources along with the activity. Okay? So, you cannot possibly think in terms of doing an activity, just because the sequence is adequate, So, you can say, in case you had infinite resources available, okay, then the sequence diagram will form the lower bound for completing the task or making a schedule, but this is rarely so. We need to always stretch this particular schedule, to make sure that our resources are well used, our resources are well used. Now, for instance, let us look at the slide again, see what you got there. In case you had a project and you were to perform activities, all activities as early as possible. If all the activities were to perform as early as possible, then you will get this type of a curve. This particular curve will have its hump on the left hand side, what is often known as a right skewed curve, indicating that each activity is performed as early as possible and the slacks, okay, if any, are left to the tail end. The graph below gives a cumulative curve for this particular type of diagram. It is a cumulative curve for the histogram that you see on top of it. Okay. Now, see what is happening. Suppose your boss was asking you to do this job as early as possible, okay, then you will find that all the activities will be done as early as possible, but there is one person who is not going to be happy about it, and that is going to be your accountant. Why? Because from an accountant's point of view, as soon as the job is complete, he needs to shell out money. So, from an accountant's point of view, an accountant says, why do you complete a job early? If you can delay this particular job or a task without having an impact on the overall time required for completing the project, then I would prefer that you complete all the activities as late as possible without delaying the project. So, this way what will happen is, I will need to pay the money for the work done, or the attributed expenses will be as low as possible. So, again look at the slide, we can say that we can now have another particular curve. Now, here in this particular diagram, what you see, that instead of all the activities being performed as early as possible, we have now performed all the activities as late as possible without delaying the total time required for completing the project. Now, the curve, on the cumulative curve below, you see a typical hysteresis kind of a curve, and this can, from an accountant's point of view, be very easily viewed as what we call interest cost to the project, the additional interest cost to the project. So, here you see two conflicting views, one from the top management of asking you to complete all the activities as early as possible, and there is an accountant who would like you to complete all the activities as late as possible. Now, what do you feel as a project manager? Now, as a project manager, again look at the slide, you have a totally different view of the situation. The first two views are not acceptable to you for a very simple reason. The resources required for completing the jobs are not evenly distributed over the lifespan of the project, are not distributed evenly over the lifespan of the project. As a project manager, you do not want a daily shuffling and reshuffling and adding and subtracting of people to your project, and you would like to have a steady manpower allocation to your particular job, and if this was to so happen, you are likely to have a most comfortable, peaceful kind of a sailing. So, we have seen now from the diagram, that there are three preferences for doing this particular kind of a scheduling activity. There are three preferences for doing this particular kind of a scheduling activity. Okay. Now, there is one more thing that you must remember. Whenever you are developing a schedule, you must keep certain amount of reserve times, okay, contingency or buffer. Now, these can be either built into individual activity durations, or they can be kept separately, okay, and you can keep the reserves at your project level, or you can keep these particular reserves at an organizational level. Okay. So, what is important for you to know is that the reserves are not required to be displayed to the people who are actually working on the project. From their point of view, the reserve does not exist, but at the same time the manager must at the back of his mind know that there is some leeway possible in performing these particular jobs. Okay. So, you can either take the approach of having the what you call contingency or reserve times built into individual estimates, or keep them separate. Okay. So, reserve times, though they may be kept separate, must be documented along with the data and the assumption, but as we mentioned already, we need not necessarily make this data available to everybody. Now, during replanning, in case you see that a particular project or activity is lagging behind, some amount of reserve time can be utilized. It's like spending some money, and so the available reserve for that particular project or the company as a whole will go down as soon as you use some part of it. Now, this and many other things that we are going to see ahead will bring you to one conclusion, that schedule development is not a very straightforward kind of activity. It's not a very straightforward kind of activity, and it involves sort of iterating the earlier steps a few times before you come to a reasonably satisfying kind of a schedule. Okay. So, now you look at the slide, you will see some kind of a illustration of a schedule. So, the schedule that you actually print out and put it on the board or email it to everybody, basically stays, that what are the tasks, what is the start time, finish time, when, what is the late finish, early finish, all Slack is available, free Slack, total Slack. It is not our objective at this particular stage to teach you PERT CPM. The terminology comes straight from PERT CPM topic. Okay. You can, if you are doing this particular job on a machine or otherwise, you can easily add some additional columns like who is going to be the person who is going to doing the job, and you can say where the job will be done and so on and so forth. Okay. But this is how ultimately the schedule looks like. Now, one of the things that you need to worry about a schedule, is to realize, this schedule is not going to be final, and you need to find ways and means of shortening the project schedule. Okay. Shortening the project schedule is one of the frequent requirements, of the people concerned. So, we now look at the next particular topic or sub aspect of scheduling, and that is, in case we need to shorten a project schedule, how do we do it? Now, it is possible to use several techniques, for compressing a project schedule. Okay. So, the compression can be done, either by, say, for instance, reducing the scope of the project. Of course, this would require a totally different cycle of activities, change management activities to be undertaken, but it is possible, that you can reduce the time required for completing a project by reducing the scope, thereby eliminating or scaling down certain activities that are associated with the completion of this particular task. Second way of doing it is by applying more resources. Okay. One of the most commonly used techniques for reducing the time required for completing a project is called crashing of the schedule. What it simply means is basically you are trying to reduce the time required for completing an individual activity by applying extra resource. you want a very trivial example, it's like you're giving your clothes to a laundry, and in case you want them urgently, you pay a little more money, and the time required for the turnaround time for getting your clothes back is reduced. Okay. Now, the crashing cannot be applied indiscriminately. There's something very interesting about the networks, and that is, in case the time required for completing a critical activity gets delayed, then the time required for completing the project also gets delayed. But this is not true, in case the time required for performing a critical activity is slashed down. Why? For a simple reason, there may be more than one critical paths, or when you reduce the time required for performing an activity, some other path may become a critical path. Okay? So, when you are doing the crashing, okay, it is not possible for you to reduce this particular kind of a time by applying all extra resources and making the trade off. No, what you need to do is, at every step find out how much reduction can be obtained by applying how much resource to which particular activities, and then maybe draw a simple Pareto kind of a chart and say that initially you would like to have minimum expense or maximum schedule compression, and progressively you will have to pay more and more and more for compressing the schedule to the same extent. Okay. So, the least incremental cost kind of approach will have to be used here. Okay. The disadvantage is that this will mean that the crashing will have to be done usually one unit at a time. So, this is a disadvantage, and you often require that you do that. Another dangerous way of compressing schedule is what we call doing fast tracking. Okay. What is fast tracking? It involves doing some activities in parallel which would otherwise have been done sequentially. There are many situations where we do this particular kind of a thing, like you look at it, many kind of computer architectures, will go and say that while you are still executing the previous instruction, they start breaking down the next particular instruction, and all this effort will go waste in case there is a if statement or some kind of a deviation of the route, and from the current instruction that is being executed there is a jump to yet another place. So, obviously all the earlier work that you did in breaking down the next instruction and being trying to save time goes waste. Let us take a simple example. Suppose you are preparing a proposal for one of your clients on the other side of the earth. So, whatever is your end of the day is the beginning of the day for that particular person, and one day your morning or that person's morning, he sends a message saying that I want a proposal for doing a specific small job by the end of the day. Of course, to you it means staying overnight and doing this particular job. That is fine, but your company may have a requirement that you cannot send a proposal to the client or make a proposal to the client unless it is thoroughly reviewed. Now you have a problem. Not only you need to stay whole night and you don't know when you are going to complete this particular proposal making, somebody will have to sit late with you and also do the review, and that person's time is going to be really wasted or difficult to sort of put in place. Now, suppose you have a great deal of experience in making similar types of proposals, and your prior experience shows that you rarely make mistakes in doing a proposal. It is possible for you to fast track and do the proposal and send it to the client and concurrently send the proposal for review. Now, here you are taking a big risk, in case the review finds some mistake, you may have to sort of eat your words and approach the client and ask for some modifications or something. This kind of thing can work very well in case you have a very good client relationship, but may not work in other situations. Okay. So, fast tracking is an activity which you should not always do unless you have very good deal of confidence in the type of work that you are doing. Here the disadvantage is, okay, increasing the project schedule at the risk of having to redo certain work that you have already done. Another important consideration in preparing a schedule is leveling of resources. We already made a reference to it earlier. Now, what happens is, if you were to undertake a mathematical analysis, and it may suggest a schedule which may conflict with the availability of resources. So, many times you need to have heuristic approaches that can be used for partly resolving the leveling conflict. Remember, the basic idea behind leveling is this, that if you can have a uniform requirement of a resource, it seems to solve many problems. Take a simple example. If you require a programmer to be with you for 2 days and then not be with you for 1 day, and then again be available for 1 day and not there for 2 days, this kind of a arrangement is going to be more difficult. Yet rather that this person works with you for prolonged periods of time, like say month or 2 months or something like that. So, this may involve that occasionally you may have to hire out some minor resources for a day or two, or it might have a situation where the person may not have work for a day or two. Okay. So, heuristic approaches can help you in partly resolving the resource leveling conflicts. Okay. You may take care of some of these things by applying extra resources, but this does not really work out very well, and you need to use different techniques for doing it. Resource leveling often results in project schedule becoming longer than the preliminary schedule or the minimum possible schedule that you have. Okay. And in that particular sense, occasionally you might like to have take recourse to things like extended working hours, weekend work, shift work, use of different technologies, or maybe hiring resources from outside for small durations of time, so that the overall resource requirement is leveled. Yet one more particular important activity that you need to do while doing scheduling is to do some kind of a what if analysis, and of course then the simulation. Let us take a simple example. Suppose we have decided to write some 5,000 programs, and we are expecting that the time required for doing each particular program is so much, and so forth. It is always likely that some of these particular activities may get performed well before time, and some of them may get delayed. Now, what you want to know, is what will happen over a period of time. So, let us take a what if analysis kind of thing. Suppose we hire an extra programmer, what is likely to be the impact of this particular decision on the project schedule, as against we take a decision not to hire this programmer, but to occasionally contract out some few programs. Okay. So, what if analysis can be made using logic networks to simulate different kinds of scenarios. Okay. So, delay in major component delivery, or introducing some external factors like strikes happening in the city, or there may be natural calamities or something like that. And in case we need to find out how will this affect the schedule, then we can take resource to, one is simple things like Excel sheet, okay, but this will give you a very deterministic kind of answers. If you want more realistic answers to your questions, then one way is to undertake simulation. So, simulation techniques are aimed at computing multiple project durations with different sets of activity assumptions. Okay. Let us take an example. Suppose we say that if I assign a work to a particular programmer, in how many percent of the situation does he complete the job before time, and how many situations does he what percentage of time he exceeds the time required for completing that particular program. Okay. Now, we may make an assumption that 90% of the time the job comes in time and 10% is the delay, but this assumption may not be correct, and in reality that person may be only 80% good in delivering that on time jobs. So, we may require to try out that in case we make an assumption of 90% on time delivery of components as against 80%, what will be the total impact of this kind of outcome on the project. Okay. So, we can use techniques like Monte Carlo analysis, okay, and make some assumptions about the probability distributions for each activity that we are performing. I gave you an example, time required for completing a program, or time required for testing a program, or the number of bugs that you expect in say 1000 lines of code, all of them could really be depicted as some kind of probability distribution. Okay. And then based on this we can get a distribution of results that are likely to come, probable results with different particulars. Once we have this situation in our hand, we can use the simulation techniques, for assessing the feasibility of the entire project schedule in face of adverse conditions. Okay. Also, the simulation will help you in preparing mitigation plans and contingency plans to face the undesirable situations. So, you can try out these particular situations and find out whether you are well within your risk profile or you are not. So, when you have done all these particular considerations, so right from sequencing to availability of resources, trying out different alternatives, crashing of networks and fast tracking and leveling of resources and all that, ultimately some kind of a schedule will come out for your project. Now, after all these problems, you would have sort of expected the schedule to run without any problems for the rest of the project's life. That is not so. Changes are inevitable, changes to every aspect, from the scope to quality to schedule to many other particular things are inevitable. Okay? So, you will find that during the life of a project, various aspects pertaining to schedule may change. A change in availability of resources is the simplest thing. Take a simple example, if somebody promised to give you 10 persons with a say Java skills, and ultimately you end up with getting 3 persons with experience and 7 persons who are fresh trainees, they are going to have a direct impact on your project schedule. You might have to do many things, including for instance arranging some kind of training for these particular people. The number of mistakes that they make may be on the higher side, and so on and so forth. So, from your particular point of view, please remember the revisions will always happen. Okay. If there are revisions to your schedule, that may change your critical path. If you change your critical path, it may have a different impact on different aspects of scheduling, like resource requirement, that pattern that we might have chosen. Okay. And many of the project's decisions may have to be either reversed or totally deferred or deviated, scrapped or whatever. Okay. So, proactive project team always stays on top of the changes, and if they stay on top of the changes by anticipating, remember, more the uncertainty, more the need for planning, and always say think before and not after. One of the quotes says, plan is nothing, planning is everything. Think ahead, that is the point. So, if you keep on doing this, then you will be able to take more informed decisions and make changes to your decisions when required. Now, making changes is only one part of the story. Communicating these changes, okay, to the stakeholders who are affected by this particular kind of change is very important. Okay. So, you need to be sort of on top, not only in making the changes, but conveying these particular changes to the concerned stakeholders. So, we come to the last process, the schedule control process. Schedule control process is concerned with, first, influencing the factors that create schedule changes. You would like to influence these factors in such a manner as to keep the number of changes to a minimum or the quantum of change to as small as possible. Second, determining that the schedule has changed, okay, and once you have made the changes to schedule, managing the actual changes as and when they occur in terms of their being properly, adequately brought into the plan and performed. Okay. So, influencing the factor, determining the schedule changes and making those particular changes and all the corresponding activities is what is achieved by the schedule control process. Schedule control activity must be integrated with the overall change control processes of the project. Remember, we have a change control process in every knowledge area. For instance, we have a scope change control. Now, we have schedule change control, we will have quality related change control, we have risk related change control, we have procurement related change control. All these change controls must be integrated in our last knowledge area of project integration or integrated sort of change control process. Okay. So, the integrated change control process incorporates change control sub processes from the other 8 areas, Now, when you are doing this schedule control, you must do some reality checks. For instance, do not be a prey to unreasonable pressures from senior management and marketing department for making commitment to a schedule which you can't meet. Especially the marketing people in their zest for getting orders may go and make commitments which are not realistic. Okay? Never hesitate to call a spade a spade. Get all the affected stakeholders involved in preparing the schedule. Okay? It is not a theoretical schedule that you are preparing on a piece of paper. Ultimately, what is important is that this schedule works in practice. How will you be sure that this particular schedule works in practice unless all the people who are affected by the schedule concur with the schedule? Okay. So, you must involve all the stakeholders in preparing the schedule and obviously have their tacit acceptance of the realisticness of the schedule. Then prepare a detailed schedule and get the stakeholders approval where possible in writing. In many cases, customer for instance, it would be good idea on your part that the schedule is formally accepted by the customer. Okay. So, getting the schedule done and getting it accepted is a totally different particular activity. Schedule progress meetings with the stakeholders periodically must take place. These particular meetings will take place at 2 levels, at a minor particular thing is within the team, and then at the project level with the project manager, and then with the top management when required with the customer. Okay. So, your progress meetings will highlight or bring out if there are any problems with the schedule, okay, and those particular problems must be taken care of and resolved. Always remember, do not spring any surprises at any of the stakeholders. Do not post facto say that this particular thing will be delayed, okay, and you anticipate and say that this is likely to be delayed. How the conflict is to be resolved, let all the concerned people put their heads together and come out with the agreed modification. Okay. So, schedule control must be done. Once you have done this particular modification to the schedule, if at all, then updating this schedule on wherever all the files and computers and all that is equally important. Agreeing on a schedule and not putting it in writing and making the appropriate changes at different particular places, it will be of no use. So, whenever you are doing this particular kind of a thing, after completion of the activity, the actual completion times should also be documented. Revisions to the schedule of incomplete activities, if any should also be documented. And once you have done this particular job, then your schedule control can be, somewhat in place. Okay. So, remember, try to influence the changes so that they are kept to a minimum in quantity or at all. Next is make sure that they are properly incorporated in the schedule and conveyed to all concerned people. Now, we come to the next particular part. What do we do with all this complications going on of schedules being made and the resources being in scarcity and all that? And that is, we need some help. Where does the help come from? And one of the simplest places to expect help, is to have some kind of a software support for project management. Obviously, software support for project management is not restricted only for schedule management. It is also available for other knowledge areas, but it has a particular use in schedule management. Now, let us look at the slide and say, okay, typically what kind of assistance can we expect, what type of assistance can we expect from a software in our schedule management? First and the foremost, the software can very easily help you in determining the critical paths. An activity which will take you a very long time to do by hand, especially if the number of activities is large. Then preparing reports, all kinds of reports are required, critical task, milestone reports, today's task starting, today's start finishing, which were supposed to start today and didn't start today, and so on and so forth. You need to prepare reports. Then you need to view the data, you want to see on a display screen a PERT chart or a Gantt chart, of the schedule. It should be possible. If you use filters, then you can see selectively look at the data that you want. For instance, you are interested in the resource required, for doing the software design, then you can hide the other things, or you can look at the work of a software designer and as to his availability. Okay. So, you can filter out the activities which we do not want. The software can also help you in doing what if analysis. Similarly, a DSS module can be incorporated for analyzing different trade-offs, and you may also have some kind of warning system where you say if a particular activity was to get delayed beyond a certain particular point, then the machine would automatically warn you that there has been some delay. The machine can also be very useful for communicating and exchanging data with the stakeholders, okay, and obviously for doing any other mathematical kind of activity. To summarize now, okay, we can say that project time management process, okay, is aimed at making sure that the project does get completed on time. It consists of basically 5 sub-processes. First is the activity definition process. In this particular process, we identify the activities. In second process, we sequence these particular activities, determine what is the precedence between the activities that is to be done. Then here at this particular stage, we have seen that we can use 2 types of networks, PDM and ADM kind of a network, and depending on the appropriateness of these particular networks, you can choose one to depict it. Then the individual activities need to be estimated for in terms of time. We are going to see more about it, in the subsequent topic on estimation, but at this stage, it is enough for us to say that individual activity needs to be estimated for the duration, time required for completing this particular job. Then we have a schedule development process. Now, schedule development is different from sequencing in that it sort of looks at the availability of resources, okay, and availability of resources and the requirement of resources together put conveniently will give you a schedule development process. Here we have also seen that many times you need to make changes and you will need to do activities like fast tracking and crashing and simulation, and basically the schedule development will be a iterative process. Last but not the least, our usual background music, that no schedule is going to be perfect, it will require changes for a variety of reasons, and in case we have to make changes, then the changes must be done in a controlled manner. So, this, if you look at the slide, will bring you to the end of our session on project time management process.